Okay, so welcome everyone. Thanks a lot for attending the webinar. Um, this webinar will include a live demo. So if well, with all the dangers that a live demo entails, but I hope everything is going to be all right. Um, you can use the GoToMeeting interface to ask questions at any time, so raise your hand to to be able to speak. So let's start with today's webinar, which, as you see, it's called New Features in OpenNebula 4.0, called the name Eagle, which has just been released last week. My name is Constantino Vázquez, and I work for the OpenNebula project as an OpenNebula engineer. That's my Twitter account in case you want to get hold of me. And I'm also actively participating in the OpenNebula users mailing list. Okay. Okay, so Sebastian, it's complaining about the audio quality. I'm going to try and speak louder and closer to the mic. So, okay, let's start. These are the contents of today's webinar, just a brief introduction on what is OpenNebula. Then we'll move on to a live demo featuring the new functionality in OpenNebula 4.0. And then we'll end with a couple of slides on who's using OpenNebula and a session of questions and answers. Okay, so what is OpenNebula? OpenNebula it's virtualization tool, a cloud management platform, which allows you to turn your physical infrastructure into virtualized infrastructure. So as such, it lets you to build different kinds of clouds. We can start talking about the public cloud, which is basically a private cloud that exposes a public interface, a simple web interface that has access to raw infrastructure resources and that features a model of pay as you go. So you pay for exactly what you need for what you're going to use. And one of the illusions that it creates is that it has an elastic and infinite capacity, since the user can request as many instances of virtual machines. It's not really that the capacity is infinite, right? But it's the illusion that the user doesn't care about the underlying infrastructure that makes this infinite capacity illusion a reality for the end user anyway. Okay, so OpenNebula has several public cloud interfaces like Amazon EC2 and OCCI, and as such, it lets you to create public clouds. OpenNebula also lets you to create private clouds, which is basically a public cloud behind the firewall. This what's the beauty of it is that it can simplify greatly the internal operations, so it flexibilizes the usage of the resources. Okay, sorry about the audio quality. I'm not sure what I can do though. I'll try to speak slower maybe and get closer to the mic. Okay, so basically it allows a CMP as OpenNebula. It allows to the dynamic allocation of resources on your infrastructure, and it also offers a higher utilization and operational savings regarding the usage of your physical servers. Another type of cloud that can be built with OpenNebula is the hybrid cloud, which basically allows you to supplement the capacity of the private cloud um, using a public cloud. So imagine you have a private cloud where you run some services, and there's sudden increase in the demand for that service. So you need more computing power to satisfy these peak demands, but you have run out of capacity in your local infrastructure. So with OpenNebula, what you can do is you can outsource some of these virtual machines to a public cloud, like for instance Amazon. In this way, you will attend these peak demands, but you don't have to take care of the burden of maintaining several physical servers in your infrastructure that are just going to be used some few days a year. Okay, so the technology that one of the technologies that allows you to create those three types of clouds is OpenNebula. So we're basically going to see today um, what's the OpenNebula model, for instance. So these are the key features or the characteristics that make that defines OpenNebula. So one of them is the adaptability. So it features a really modular and plugin oriented architecture that at the end of the day, what it means is that the OpenNebula core just manages abstractions of the resources, and then the actual operations are performed by little little scripts or little programs that know how to do a particular functionality with a particular technology. For instance, there's you have the deploy script that is the one that launches the virtual machines for KVM, for instance, and there's another version for Sheng and another version for VMware. So they are simple scripts that really gives the OpenNebula the adaptability to fit into any data center, because the integration capabilities are are very good. So it's also an enterprise ready product, so it comes with an upgrade process, and it also features commercial support given by C2G Labs. Uh, it ensures not to fall into the vendor lock-in, since it's platform independent tool. It's also light. The memory footprint of the OpenNebula core is really small. It goes up to 150 megs when it's managing tens of thousands of resources. It's also proven. It's been around for over 5 years now, so it has been tested by the community, and it's mature since it's basically widely used. It's also a powerful piece of software. See, it has lots of advanced features for virtualized environments. It's scalable. It's been proved that a single instance can run as much as 16,000 VMs in a pool of 400 physical servers. But it doesn't also it does also features multi-die architectures with the help of the Ozones component. It also features a rich set of APIs and interfaces to foster interoperability between different clouds. And the last but not least is an open source project. It's based in the very unrestricted license of Apache version 2. Okay, so moving on a bit on the new features in OpenNebula 4.0, maybe the most highlighted one is the complete facelift for Sunstone. If you have used Sunstone before, you will notice that has been completely revamped. The style and also the functionality and the workflows, more importantly, at the time of doing things like, for instance, create clusters and add hosts and networks and data stores to clusters. Now it's been greatly improved. For instance, the ability to do inline editing and so on. We'll see this in a bit in the live demo. Um, There's also support for snapshotting, so you can do a snapshot of your virtual machine and then revert to that snapshot if you fail to install some particular package, for instance. It also features hot plug for network interfaces, so you can have your virtual machine running and then add a network interface to it without having to shut it down. Also, OpenNebula Eagle features the ability to do hot disk save, so that means to take a snapshot of just a disk when the virtual machine is running. You have to be careful with this feature because if the guest operating system is right into the disk at the time you're taking the hot snapshot, then you will end up with an image that is corrupt. It also features vertical scaling, meaning that you can have a definition of a virtual machine, and then you can increase the capacity, the memory, and the CPU. There's also a cool new feature called the action scheduling. So you can schedule actions basically for your VMs. So you can set an action to shut down my VM this Sunday at 10 o'clock in the morning, for instance, or stop it and then bring it back next week, Tuesday morning. There's also have been a lot of command line interface improvements. So people that are more hardcore sysadmins, they can use and that they use the command line interface. They will notice that, for instance, the creation of resources in OpenNebula doesn't depend anymore on the creation of files, but you can specify the characteristics of the newly created resources by using flags in the as arguments in the command line. Like for instance, one VM create dash dash name, for instance, something like that. There's also a number of new drivers, like for instance, the new storage drivers for Ceph that I encourage you to try them out and give us feedback because it's really important to get them as polished as possible. Okay, so let's go for the live demo. So I'm gonna open a tab to OpenNebula Sunstone. So as you see here, I'm logged in as one admin, which is the administrator user. And as such, I can see the whole picture of my cloud. I can administer and manage the physical resources as well as the virtualized ones. So for instance, in system, I have access to the users tab. So you can see here several users that I'm going to delete. And I'm going to create a normal user for the demo. I have here access to groups. I have access to the ACLs, which are basically the rules for the access control lists. So this gives the ability to, for instance, create rules to allow groups or certain users to, for instance, manage or administrate or create virtual networks. So this allows for a fine-grained control of the resources and their use by the users. I also have access to the virtual resources like virtual machines, templates, images, files, and kernels, which is also a new feature of OpenNebula 4.0. You can store files and kernels on the data stores. You have access also to clusters, to hosts. I have here a host defined. I can see here the monetization attributes. And this is a new feature of the new Sunstone. So I can set here labels like label green, for instance. So I'll have here this label green, which allows me to create placement rules for virtual machines, for instance, with these requirements. So you can create a virtual machine and say, okay, I want this virtual machine to be run in hosts with this label green. That be it. Um, Another cool feature of this inline editing is that you don't have to delete it, but you can change it. So I can say, okay, this host now is going to be red. We have some graphs of the usage of CPU and memory over time by this host. Um, the one admin also have access to the different data stores. So I have here my system data store, which is configured with the shared driver. I could change this easily by, for instance, turning it into SSH, but we are not going to do that because the demo won't work. Um, I can also change permissions, so I can give the group that owns this data store, in this case, one admin, the ability to manage it, for instance. I can change the ownership of the group, so I could have set this data store to be used by my user, but it also will defeat the purpose of this demo, so I won't do it. And there's also the files data store, and the default data store. This is the one where we are going to store our images and snapshots and so on. So as you see, I have this configured with the shared transfer manager driver, and it's of type file system. And these are the images that I have in this data store. In this case, I have a Windows XP image that we are going to launch now. We also have some virtual networks. In this case, this is just a demo network with some leases. So I have here a network that starts giving leases from IPs from 10.0.0.1 and ends in 10.0.0.100. So let's see if I switch users. So for instance, I can, well, here I can change my language. There's 17 different languages that you can customize your configure your OpenNebula Sunstone. And you can also add some custom attributes to the user, and you can change the views. So for instance, let's change it to the user view. So with the user view, even if I'm with the one admin user, I only will be able to see certain resources. So as you see, the system tab has disappeared. I don't have access anymore to users or groups or ACLs. And infrastructure, I lost the views of the hosts and of the clusters. Okay, so this is the default behavior. You can change that easily in the Sunstone's view configuration file. So you can define your own views for certain users or certain groups, or you can change the behavior of the default admin and user view as well. This is the marketplace tab. It's basically making something to connect to a service, to a server offered by C12G with different pre-configured images to be used straight into your infrastructure. So you can import these images straight to your infrastructure, and OpenNebula will download them and then let you create a virtual machine out of it. So let's create a template. So let's delete this last one and create a new one. So this is going to be my demo VM. I'm gonna set it to some amount of RAM, and I'll use the Windows XP image. I won't give it any network, so we can try the new add network interface functionality. We don't need to set any of these for Windows in KVM machines. And I'm going to add a PNC interface so we can see what's going on inside the Windows machine. So that will be it. So I create the template. So this is a virtual machine template. I can instantiate as many copies of this as I want. So let's instantiate one. Okay. So I have a virtual machine running here that is using my VM, so let's get rid of it. So this copy of Windows, shut this down. Sorry. Okay. So sorry about that because I have a copy of Windows that is in Spanish. Now it's installing some upgrades. Okay, so let's wait until it's done. Okay, so now the machine is not running anymore, so I can safely delete it. Since I was using persistent image, you can see here it's persistent. So I could only have one instance of the template running because uh, this is basically running from the source image. So all the changes that I do, they will make it back to the image. So if I have two virtual machines running with the same persistent image, uh, OpenNebula wouldn't know which changes were fit to be saved back. Okay, so I have this template now. Hopefully I can instantiate it. So here I see my virtual machine, my new virtual machine. It's in the prologue state, so it's copying the image. Shouldn't take very long. So I'm gonna change back the view to the admin user. Hmm. Okay, so we have it in running now. Let's see. Okay, it seems like the Windows machine is starting up. Okay, so let's log in. And let's see, for instance, if we have a network. So if I ping Google, this is the Spanish message saying that you cannot find the host Google. So let's add a network interface. As you see, the virtual machine here has its own tabs in the lower section. So this is information about the virtual machine. I can change the name if I want to, change the permissions, the ownership, and so on. I could also resize the capacity of the VM. The storage, I can add new storage disks. So for instance, if I create here, an empty data block, so I create an empty one of say half a gig and of type Pro. So I see here that the image is ready. So let's add it to our running virtual machine. Here's the data block. So I'll attach it. So the image is probably now being copied. Okay, so here you find an error message saying that it couldn't attach because it's trying to attach it in the IDE interface, and we need it to be SCSI. So we just delete that, go into the image, and say, okay, your prefix, you are not going to be an IDE device, but rather an SD device, an SCSI device. So now I can repeat the process and attach the same image. Hopefully now we will see it. I can change the. Okay, so now the data block is here. I can create a snapshot, for instance, of my main disk, or a snapshot of the data block. Say that I put some files on it and I want to save it. So I can say it, my save data block, for instance. And this is two options that I have. It can be a deferred snapshot, so the snapshot will be made as soon as the virtual machine is shut down, or I can make it a hot snapshot, and the snapshot will happen as soon as I hit the take snapshot button. So the snapshot is in progress now. Meanwhile, let's try and get internet on the machine. So I cannot ping Google. Let's add a new nick. So I'm gonna pick an IP address of the pre-created virtual network. Hit attach. Can check the log. Okay. See the network. It looks like I have a network. So let's see. Okay, saying that I don't have a lot of space in the disk. Never mind. So now I have a network card and I'm able to ping Google. So this is one of the nicest features, the ability to attach new nicks while the VM is running. I can also take a snapshot of the full system. So this will take a snapshot of both all the disks and also the memory state of the virtual machine. These are the rules of placement. So, for instance, here I could see if this virtual machine has particular requirements at the time of pick a host to be run onto. And this is one also of the newest features is the ability to schedule an action. So I can say, okay, I want you to shut down or any of these other options. This machine, for instance, yeah, today in, let's say, uh, 6 o'clock, for instance, or maybe 45. So here I can see the actions and I can delete them if I don't like them. Here is a text representation of my virtual machine, so I can use this as reference to see some low-level details, like for instance the source of the disk that this image is using. This tab is only presented to administrators users, not to normal users. So these are more or less the new features that I wanted to show of OpenNebula 4.0. I'll move back to the presentation and tell a bit about who is using OpenNebula now. So OpenNebula it's been around for, as I said before, 5 years, and there's a grand number of big users that use OpenNebula to operate their enterprise private clouds in the medium to large data centers. So we can highlight companies like Research in Motion or Fermilab or ISA, China Mobile, and Akamai, for instance, running some of them data centers using OpenNebula. In a survey that we did at the end of last year, the middle of last year, we can see how OpenNebula is being used in industry most of all. People use it 50-50 in production and testing environments. Also, if you want to try out the new OpenNebula and you don't want to go to the whole process of installing it from the packages, you can use one of the cloud sandbox, which are virtual appliances that you can download and launch in your favorite hypervisor like VirtualBox or VMware or KVM, or you can even launch an AMI instance with Amazon, and you'll end up with a fully functional cloud of OpenNebula with some pre-configured images to be launched inside the virtual machine. So you can have the full experience of a cloud in just one box. Okay, and last but not least, I would like you to invite all of you to the OpenNebula conference that will happen in Berlin in next September, 24 to 26. We have some really nice keynotes with one of the biggest OpenNebula users around the world, and we'll also have the chance to meet the OpenNebula team and have some beers. That's all I'll like to talk about today in this webinar. If you have any questions, please use the OpenNebula user mailing list, or just simply direct your questions or doubts or love to the OpenNebula account that's at Twitter, that's at OpenNebula. Okay, so now if you have some questions, it'll be the time. Okay. So there's a question of Paul Van Buren saying that when I set CPU at 0.2 and vCPU 4, tell me in what percentage, what is the difference in performance when I choose one CPU and one vCPU? Well, basically, CPU, it's an indication of how many physical CPUs you're going to use. So if you set a CPU at 0.2, then you're going to use 20% of one actual CPU. If you set vCPU to 4, then the guest operating system is going to believe that it has 4 CPUs, but actually all these 4 CPUs it will be using 20% of one CPU. Um, so the difference in performance is that when you choose one CPU instead of 0.2, then you're going to have 5 times more real CPU for your virtual machine. And vCPU really only affects at how the operating system sees um, the virtualization environment. But if you use VMware or KVM with C groups and you set CPU to 0.2, then you're only going to get 20% of CPUs, and the guest is going to believe that it has 4 CPUs or whatever. So what are the requirements to do a hot snapshot? Basically, the requirements would be to end up with a meaningful snapshot. You will need to sync the guest operating system and to forbid it to write to the disk. If that's tricky to do, or user is not able to do it, then you'll have to do a deferred snapshot. So Sebastian is also asking about memory overcommitment. So memory overcommitment, how it's handled is that basically um, at OpenNebula 4.0, it's really easy to do a CPU overcommitment, but with memory overcommitment is not that easy. I mean, by default, OpenNebula just discards 10% of the memory of the hosts, and it won't do any overcommitment. This is a feature that can be interesting, and we can talk about it to include it in the roadmap for 4.2. I invite you to join us in the OpenNebula channel at Freenode next Thursday at 5 o'clock in the afternoon CES time as well, to discuss new feature requests that can be added to the OpenNebula roadmap. So Sebastian is also asking when is the Foreman FOC integration ready? So it's a really nice question. Hopefully it will happen for OpenNebula 4.2. But again, we'll have to define the roadmap and see if it's going to get it in or not. Okay, Sebastian, yeah, definitely. See you in Berlin. Okay, I think I have a. Okay, so it's Rashid Mohammed that wants to share something with us or ask a question. I will give you access to the mic, Rashid. So go ahead. Hello, Rashid.
Yes. Can you tell us the status of NetApp driver?
Okay, sure. So basically, oh, sorry, sorry. Say again.
We want to know the status of NetApp driver.
Okay. So basically, what happens is that how OpenNebula uses NetApp cabins is using the NFS protocol, so it doesn't really work with NetApp directly. But there's some contributions by Cisco that you may be interested in. You can check it out in the OpenNebula wiki, and it's support for the flex clone operation of NetApp. So that's a start. We're going to keep pushing that integration, and hopefully it will be available also for 4.2. But again, I invite you to join the IRC meeting and let us know about your interest in this driver. So is that Did that answer your question, Rashid?
Yes, thank you.
Okay, thank you very much. So, any other question? Okay, so thanks a lot for attending the webinar, and see you around the IRC or see you around in Berlin. Have a good day. Bye bye.